Welcome to Talk Tickers. Today is Wednesday, January 28th, 2026. Usually we are here breaking down earnings calls, digging through 10Ks, but today we are looking at a pivotal news event for Tesla. And honestly, it feels like an earnings call in disguise because the financial implications here are just massive. The headline on the wire is that the 4680 battery cell is officially going back into the Model Y. If you read the press release, it just screams technology breakthrough.
Yeah.
But if you look at the balance sheet and, well, more importantly, the geopolitical map, it tells a very different story. It says tariff hedge.
It absolutely does. The stakes here are incredibly high, and I think the market is kind of glossing over just how critical this move is. This isn't just about, switching out a battery cell form factor. It is about a fundamental shift in how automobiles are constructed, the potential death of the traditional supply chain, and honestly, how a commercial misstep, and we have to be real about the Cybertruck numbers here, is forcing Tesla's hand on their highest volume seller.
We have a heavy stack today. We are going to break down this new battery lineup for 2026, which is surprisingly complex. We're going to look at the economics of gigacasting, which is totally rewriting the manufacturing rulebook and not necessarily in a way that benefits the consumer. And we're going to look at the brutal reality of the automotive lightweighting war. But let's start right at the top with the news of the day. As of today, Tesla has restarted building Model Y battery packs using in-house 4680 cells at Gigafactory Texas.
Right. And to understand why this matters, you have to sort of ignore the marketing fluff. The official line from Tesla is that this unlocks supply vectors. It sounds nice, doesn't it? It sounds like growth. But the subtext is purely defensive. It's about navigating trade barriers. We are seeing Chinese battery suppliers facing export restrictions and significant tariffs. Domestic production in Austin isn't just a nice-to-have capability anymore. It is an insurance policy. If the border is close to Chinese lithium or finished cells, Tesla needs a domestic supply just to keep the lines moving.
It's a survival mechanism. And they are hitting a milestone here that we've been waiting for since, Battery Day in 2020? They are now producing dry electrode cells, where both the anode and the cathode are made domestically in Austin. I feel like we hear dry electrode thrown around constantly, but for the uninitiated, why is the dry part such a big deal? Is it just about speed?
It's about footprint and energy, which at the end of the day means margin. Think about the traditional wet process used to make batteries for the last 30 years. You mix battery active materials powders with toxic solvents to make a wet slurry. You coat that onto a metal foil, but then you have to dry it. You need these massive football field-sized ovens running at high temperatures to bake the solvents back out and recover them.
You're paying for the energy to wet it and then paying again to dry it.
Exactly. It's incredibly inefficient, it's energy intensive, and those ovens take up about half the factory floor space. The dry process, it skips the slurry entirely. You take the powder, you mix it with a binder, and you press it directly into a film. If, and it is a big if, they have solved this at scale, you delete the ovens, you cut capital expenditure, you cut energy bills, and you shrink the factory footprint by huge margins.
That sounds like the manufacturing holy grail. But I'm looking at the notes here on yield rates, and it seems like that's where the dream hits reality.
That is the friction point. The goal is a 90% production yield on these lines by the end of 2026. That is the magic number. If they are scraping 30% or 40% of the cells because the film is tearing, or the density isn't uniform, or the binder isn't holding, that margin advantage evaporates instantly. You aren't saving money, you are just burning raw materials faster.
So watch that yield rate like a hawk. Now it's not just one battery anymore either. The reports we are seeing confirm a massive expansion in the product line. They are launching 4 new proprietary 4680 models by the end of this year. We have the NC05 designated for the robotaxi, the NC20 for SUVs, and the Cybertruck. And then the high-performance stuff, the NC30 and NC50.
The NC30 and NC50 are where the materials science nerds should be paying attention. This is where the chemistry is actually changing. These are featuring silicon-carbon anodes.
Silicon has been the next big thing in batteries for a decade. Every startup claims to have cracked it. Why is Tesla putting it in a production car now?
Because the payoff is huge. Silicon holds about 10 times the lithium ions that graphite does. It provides the energy density boost you need for the next generation of performance vehicles. But the problem has always been physical. When you charge silicon with lithium, it swells up like a balloon. It expands by about 300%.
Which, inside a rigid metal can, sounds like a bomb.
Or, at the very least, it cracks the internal structure and the battery dies after a few cycles. If Tesla is confident enough to put an NC50 into production, they believe they've solved the swelling issue. probably through that carbon scaffolding to contain the expansion. But looking at the other end of the spectrum, the NC05 for the robotaxi, that tells you they are trying to standardize the power source across the entire fleet. It's a unified energy platform.
I want to push back on the NC20, though. Why is this specific cell suddenly ending up in the Model Y? It was designed for the Cybertruck. It feels like a retrofit.
It is a retrofit, and this connects to the elephant in the room regarding the Cybertruck. We have to look at the sales numbers.
Or the lack of them.
Right. The Cybertruck has underperformed. It's being described in the industry now as a commercial flop. I know the fan base loves it, but the volume just isn't there. And that creates a massive industrial problem. Tesla built out massive capacity to build 4680 cells specifically for the Cybertruck. They spent billions on these lines. If demand for the truck collapses, you have idle billion-dollar assembly lines, you have excess capacity. They have to put those cells somewhere.
So the Model Y is basically the sponge soaking up the excess supply.
Precisely. It's capacity utilization 101. You don't want those lines sitting dormant. That burns cash. But there is collateral damage here. Look at the suppliers. L&F Co. recently wrote down a $2.9 billion cathode supply deal with Tesla.
Wait, did you say billion? $2.9 billion.
$2.9 billion, and they wrote it down by over 99%.
That is essentially a total wipeout. That's a contract termination in all but name.
It's a zero. They cited a change in supply quantity. That is corporate speak for Tesla isn't buying what they said they would. This signals that the original aggressive ramp-up plans for the Cybertruck, and by extension the 4680 consumption, failed. So the narrative has shifted completely. 5 years ago, the 4680 was pitched as the cost revolution that would give us the $25,000 car. Remember that?
I remember. The $25,000 Tesla was going to take over the world.
Today, the $25,000 car plan is scrapped. The 4680 is being deployed as a supply chain hedge and a survival tool to keep factories running. It's not a price-slashing weapon anymore. It's a shield against geopolitics and bad demand planning.
That is a fascinating and somewhat darker pivot. It changes how we have to look at the company's forward guidance. But I want to zoom out a bit because this battery strategy doesn't happen in a vacuum. It's happening in the context of a broader industry war over weight.
The lightweighting war. This is the macro trend that drives almost every engineering decision in the automotive sector right now.
It makes sense intuitively. EVs are heavy, batteries are heavy. But is the trade-off linear? How much does weight really matter?
Physics is expensive. The data shows that a 10% weight reduction improves EV range by about 4% to 6%. That might not sound like a lot, but when you are fighting for every mile of range to compete with gas, it is everything. And we are seeing a massive material shift because of this.
We're seeing steel, which currently makes up about 50% of vehicle weight losing ground rapidly. Aluminum is currently at 15% and climbing fast.
And it's not just consumer demand for range, though. This is being forced by the heavy hand of government regulation. Look at Europe. France has introduced the malus au poids, a literal weight tax. If your car is over 1,600 kilograms, you pay a penalty. In the US and Europe, SAF-FE standards and CO2 limits are tightening through 2030. If you build heavy cars, you are going to get fined into oblivion. So the OEMs have no choice. They have to cut fat.
So how is Tesla cutting that fat? This leads us to the manufacturing revolution.
Yeah.
Gigacasting. I've seen the photos of these presses. They look like buildings themselves.
This is where the economics get really interesting and really risky. Gigacasting is the process of using massive 6,000 to 12,000 ton die casting presses to cast entire vehicle sections in a single shot. Molten aluminum goes in, a chassis comes out.
The stats on the Model Y are wild. The rear underbody went from being 70 distinct parts welded together to just one piece. The front underbody went from over 100 parts to one piece.
Think about the labor savings. Think about the robot savings. You don't need 300 robots welding pieces together. You just need one giant press. It reduces manufacturing costs for the chassis by 40%. That is a margin unlock that is hard to ignore. It's faster, it's cheaper, and it's lighter.
And it's not just the frame, it's how the battery interacts with it. We are talking about structural batteries.
Right, the battery is no longer luggage. In a traditional EV, the battery is a heavy box you bolt onto the frame.
Wow.
In the Model Y and the new platforms, the battery is the floor. The pack links the front Gigacast to the rear Gigacast. In the Model 3, doing this eliminated 370 parts.
That sounds incredible for efficiency. And obviously the competition is watching. It's not just Tesla anymore.
No, the cat is out of the bag. Volvo is installing 9,000-ton presses in Slovakia. And the Chinese OEMs, XPeng, Huawei, Xiaomi, they are all deploying these 9,000 to 12,000-ton monsters. They see the cost advantage. But, and this is crucial, there is a hidden risk here that investors often overlook. We call it the disposable car problem.
Disposable isn't a word you want to hear associated with a $50,000 asset. What is the actual conflict here?
Gigacasting is great for the factory, but it is a nightmare for the repair shop. If you get into a minor accident in a traditional steel car and you bend a bracket or crush a fender support, what happens? The mechanic cuts it out, welds in a new $50, paints it, and you're back on the road. Steel bends. It has memory. It can be worked.
But with a gigacast aluminum frame...
Aluminum doesn't bend like steel. It cracks. If you crack a gigacasting, you cannot just replace a bracket. There are no brackets. It is one continuous piece of aluminum that spans the width of the car. To fix it, you would effectively have to replace the entire underbody of the car.
Which is basically impossible, or at least financially insane. You'd have to dismantle the whole vehicle.
Exactly. Repair costs skyrocket. We are seeing minor collisions, things that used to be $2,000 fender benders, rendering these vehicles unusable. They are becoming total losses. The insurance company looks at the crack in the casting and says, we can't fix this safely. This is capital-intensive infrastructure that makes cars harder to insure and harder to fix.
So we have this tension between highly efficient manufacturing and highly inefficient repairability. That creates a weird dynamic in the insurance market.
It does, and it raises an important question for the long-term value of these assets. If a car is totaled from a minor hit, insurance premiums have to go up. Eventually, concessions might push back because the cost of ownership becomes unpredictable. But for now, the manufacturing cost savings are so high that OEMs are willing to take that risk and pass it on to the insurer and the consumer.
Before we get to the trade idea, I want to briefly touch on the robots. We mentioned the new batteries coming in 2026, the NC30 and NC50 with silicon carbon, but there's another piece of hardware these batteries might end up in. We're seeing reports of LG Energy Solution pursuing a battery deal for the Tesla Optimus humanoid robot.
This connects to that unified energy platform idea I mentioned earlier. Tesla isn't just building cars, they're building autonomous agents. Whether it is a robotaxi, NC05, or a humanoid Optimus, they all need high-density, reliable power. If LG is getting involved, it suggests that even with the Austin ramp, Tesla might need external partners to meet the volume demands for robotics if that program actually scales. It shows they're hedging their bets even on the future tech.
So to summarize the landscape before we get to the money, we have a tariff hedge, a manufacturing revolution that creates disposable cars, and a unified battery architecture designed to save a struggling supply chain.
It means Tesla is hunkering down. They are securing their supply chain against China. They are doubling down on the manufacturing method that saves them the most money. And they are trying to salvage the 4680 investment by pivoting it away from the failed Cybertruck volume and into the Model Y. It's a defensive play masked as an offensive technology breakthrough.
That is a serious sober check. Okay, let's shift gears. We've analyzed the news, we've looked at the tech. Now let's talk money. It is time for our This Is Not Financial Advice segment.
All right, let's look at the market dislocation here.
We pitch a trade idea based on the deep dive. It's outrageous, it's plausible, and it's definitely not financial advice. Do your own diligence. What do you have for us?
Okay, here is the pitch. Based on everything we just discussed about gigacasting and repairability, I want you to go long the scrap metal arbitrage and short general collision repair.
Shorting the local body shop feels un-American. What's the logic?
Look at the thesis. We just discussed gigacasting. Tesla, Volvo, Xiaomi. They are flooding the market with cars that are structurally integrated single-piece castings. When these cars get into accidents, they are not getting fixed. The total loss rate for minor accidents is going to spike.
So a body shop loses the business because the car never makes it to the lift.
The body shop can't fix it. They look at a cracked rear underbody and say, I can't weld this. I can't order a replacement section. The insurance company writes a check. The car goes to the salvage yard. But here is the kicker. These aren't old beaters with 200,000 miles. These are brand new 2026 Model Ys and Cybertrucks full of pristine, high-grade aluminum and brand new battery materials.
So the value shifts to the recycler.
Exactly. You want to buy broadly into high-grade aluminum recycling specialists and specialized heavy-duty salvage auctions. The recycler gets a 60-kilogram single-piece aluminum casting that is easy to melt down because it's one consistent alloy. They get the battery pack materials, which are barely used. The value of the wreck is higher than ever, but the value of the repair is zero.
You're betting on the inefficiency of the repair market.
I'm betting on the disposable car economy. As long as OEMs prioritize assembly speed over repairability, the volume of high-quality scrap is going to go parabolic.
What's the risk? Where does this trade blow up?
The risk is that the OEMs figure out a modular repair kit for gigacastings. If they invent a way to patch these things safely, some kind of high-tech bonding agent or bolt-on fix the trade collapses because the cars stay on the road. Or if insurance premiums get so high that consumers stop buying unrepairable cars, the volume dries up.
But until then, the scrapyard is the new gold mine.
That's the trade.
Love it. All right, let's wrap this up. Recap for the listeners. The 4680 is back in the Model Y, but it's really about dodging tariffs and hedging against China. We've got 4 new battery types coming in 2026, including that silicon carbon tech for the performance trims. Gigacasting is winning on the assembly line, but creating a massive headache in the body shop.
And the signpost to watch is the yield rate. Keep your eyes on the Austin dry electrode line. They need to hit 90% yield by year end. If they are stuck at 70% or 80%, the margin story they are selling collapses.
And here is a final thought to chew on. If we were moving toward an era of the disposable car, where a single crack totals the vehicle, does the concept of ownership even make sense anymore? Or does this inevitably push us all toward a subscription model where the manufacturer owns the risk and you just pay for the miles?
If I can't fix it, maybe I shouldn't own it.
Thanks for listening to Talk Tickers. Keep your eyes on the tape.
See you next time.